Standard 22 here, we have our sum and difference identities, so we have some more formulas to go over, okay? So I'm going to start writing the first one for you. If we have the sine of x plus y, guys, it's not just sine of x plus sine of y. You could think on your circle, sine of 30 plus 60 is not the same as sine of 30 and sine of 60 added together. But so that's why we have to do these formulas. So the first one here is sine of x cosine of y plus cosine of x sine of y. What do you think it's going to be if I subtract two angles instead of adding two angles? So right here, it's sine of x plus y, so I've got this thing plus this thing. What do you think is going to happen when it's minus?
Minus.
Yeah, that thing minus that thing, yes. It's going to be sine of x cosine of y minus cosine of x sine of y. Okay. So the two sine formulas are very similar. Now let's look at cosine. If it's cosine of x plus y, it is cosine x cosine y minus sine of x sine of y. Okay, make sure you've got your signs ready. So what do you think it'll be for cosine of x minus y? Yeah, a plus in the middle. So it's going to be cosine x cosine y plus sine of x sine of y. Okay. Then we have our two tangent formulas for this. So tangent of x plus y is tangent of x plus tangent of y over 1 minus tangent of x times tangent of y. So the sign in the numerator matches what you're doing with your two angles. We were adding, so that matches. And then denominator is the opposite sign. So what's the formula going to be for tangent of x minus y? Not everybody at once guess. What do you think? Go ahead, Aiden, say it again. Sorry. Good. Over. Yep. So again, the sign in the numerator always matches whether you're adding or subtracting the angles, and then the sign in the denominator is the opposite. I can tell you guys are really excited about these formulas. Alright, let me show you how to use them. Okay, so the first one here, cosine of 15 degrees. Is 15 something we know on our unit circle? No, it is not. But do we know two angles that we could add or subtract that would give us 15 degrees? 60 minus 45, that works. Do you think 60 and 45 are the only two angles you could pick? No, there's tons of options, and you will get the same answer no matter what you pick. I'm going to go with 60 minus 45. Okay. So the 60 is like my x and the 45 is like my y, if you're looking at the formula, okay? So this is cosine of x minus y. So now we're just going to rewrite it with the big expanded formula there. So it's going to be cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. So now you have to tell me, what is the cosine of 60 degrees? You guys should know these, right? What is it? 1/2. What is the cosine of 45 degrees? Good. Plus, what's the sine of 60 degrees? Good. And the sine of 45 degrees? Okay. So those trig quizzes are not just me being mean and trying to like cause you pain and suffering. It's because you actually need to remember all of those trig values throughout the year, okay? All right, now it's just multiplying fractions. So numerator times numerator, 1 times root 2 is just root 2. 2 times 2 is 4. What about root 3 times root 2? Root 6. Also over 4. So we could write that as root 2 plus root 6 all over 4. We okay that I can't reduce that? Use that? Okay. All right, questions on the first one? So you just have to pick a couple of angles, find your formula, plug it into the formula, and evaluate. It's different than the proofs. It's not where you have to come up with all this stuff on your own. There's a very systematic, formulaic way to go about this, okay? All right, so you guys try number 2, sine of 165. Pick 2 angles for me. And remember, you can add or subtract, it's up to you. But pick angles you actually know. So don't use like 180 minus 15. That's not really very helpful, okay? Pick some angles that you know. I'll give you a minute here. Seeing 120 plus 45, that's great. Seeing 210 minus 45, 135 plus 30. right, guys, look up here. When you've got it, check to see if you match. And realize that is the same thing as writing it in that order. Okay? The same answer. How'd we do? Yes? Okay, I'll give you a minute, make sure we're there. And then I'm going to jump around a little in your notes, guys, since we don't have a ton of time left. So I want to make sure we're good with the basics first. Anybody questions anywhere on this? Do you see why knowing positive or negative on those trig values is going to be very important? Otherwise, you're going to have your signs wrong again. Yeah, you should get the same answer. Did you get the same answer?
Oh, I didn't get that.
Oh, yeah, like if you did 210 minus 45. Yep, you will get the same thing. Okay, or you should get the same thing. All right, guys, questions before we move on? Okay, turn the page. I'm going to go a little bit out of order here. Go to number 5 for me. Okay, it says condense, and then I give you this cosine of 85 plus cosine 25.
Sorry, you go from. Why is tangent we plug your plug
For inverse?
yeah, like when you're trying to find values.
So you restrict it so that the function, the inverse function, is actually a function.
Thank you. We knew it was. I can't remember what.
Yeah. Okay, good. So back to this one. Cosine 85, cosine 25, plus sine 85, sine 25. We don't know any of those values, so we can't look at that and figure out what it is. But do you guys see that that's one of our formulas? Cosine, cosine, plus sine, sine. What does that look like? Cosine of x minus y, right? Okay, so the 85 is the x and the 25 is the y, correct? So that means this is the cosine of 85 minus 25. Can you subtract 85 and 25? Yes, what do you get? Oh, is that something we could actually evaluate? Yeah, what's the cosine of 60 degrees? 1/2. All right, we're done with number 5. It's going to be evens on the one that actually says homework. Okay, not the classwork one though. All right, good on 5. So if it says condense, you're just kind of working backwards from the formula. Let's look at 7. Okay, yes, this is a proof, but you have the sort of help from the formula to guide you through the proof, all right? So this cosine of pi over 2 plus theta, I can use one of my formulas to expand that. So it's going to be cosine of pi over 2 times cosine of theta. Then what do you think? Is it going to be plus or minus? Minus, good. Sine of pi over 2 times the sine of theta. Does that make sense what I'm doing there, just using the formula? Okay, I'll wait till you guys catch up with me. All right, what is the cosine of pi over 2? 0. I just have to say it over there. So I've got 0 times cosine theta minus, well, what's the sine of pi over 2? 1. Okay. What's 0 times cosine? 0. And then minus 1 times sine, isn't that just a negative sign? And then you're done. So those proofs are kind of nicer than the proofs we were doing before because you have like something to lead you through. You don't have to just come up with it on your own. Okay. right, I know I'm jumping. Back up to the top now. All right, for 3, it says you are given sine of alpha is 3 over 5, and 0 is less than alpha is less than pi over 2. Cosine of beta is 5 over 13. 0 is less than beta is less than pi over 2. Okay, that's a lot of information. What this means is you need to draw me 2 little triangles, one for alpha and one for beta. So 0 is less than alpha is less than pi over 2. That's just telling you what quadrant you're drawing it in. So what quadrant is that? First, okay. Draw my little triangle, and I'm going to put the alpha in there so I know what I'm talking about. All right, sine of alpha is 3 over 5. What does that mean in my triangle? Okay, so the opposite, the y, whatever you want to call it over here, is 3. What's 5? Hypotenuse, good. Do you guys know the other side of the triangle? 4, okay. All right, so we've used up all of that first information. Then it says cosine of beta is 5 over 13. 0 is less than beta is less than pi over 2. Well, where is beta? What quadrant? It's between 0 and pi over 2 again, right? Yeah, still in the first. So I'm just drawing a new triangle, labeling it beta, still in the first quadrant. Cosine's 5 over 13. So what does that mean? So the x value is 5. The horizontal piece is 5. Hypotenuse is 13. You guys know the other side? 12. Good. Okay. All right. So all of this information right here, all of that is given to you just so you can draw those 2 triangles. That's all it does. Then we can evaluate what it asks me for here, sine of a plus b. So if I write that with my formula, that would be sine of a cosine of b plus cosine of a times sine of b. Can you look at your 2 triangles now and fill in what those values would be? Okay. And instead of A and B, should we use alpha and beta maybe? Or change these to A's and B's? That might be easier. You like A and B better than you like alpha and beta? Okay. So what is the sine of A, guys? 3/5 times, what's the cosine of B? 5/13 plus, what's the cosine of A? 4/5 times, what's the sine of B? 12/13. It's just a matter of multiplying your fractions now. So if I multiply 3/5 times 5/13, what's 3 times 5? What's 5 times 13? 65, okay. Then what's 4 times 12? 48, and 5 times 13? 65. They have a common denominator, right? They always will unless you've messed something up, okay? So just add your numerators. What is 15 plus 48? 63 over 65. Okay, lovely answer. The sine of A plus B. Okay, we're going to stop there for notes because we're running out of time. Questions on that? None of this is really that hard other than making sure your signs are correct. If it's not in the first quadrant, you really need to pay attention to what's negative, okay? All right, homework. Find the page that actually says homework for Standard 22, not classwork. Do the evens. If you're struggling with it at all, please go back and do the odds as well. If you're catching on, we stay even this morning. We do have an assessment on 22 next time.